For the next talk, Martin is going to introduce, I guess you have like a special library to interact with GraphQL, right? So it's kind of a big topic, hot topic. Nowadays, GraphQL looks like pretty cool. I had no time to test it, but I heard some good feedbacks. Please welcome Martijn Walraven to the stage. Thank you very much.
So it's great to be here. I've really enjoyed the conference so far. My name is Martijn Walraven. I work as an open source developer at a company called Meteor. I work remotely from Amsterdam, but the company is based in San Francisco. And I work on our Apollo GraphQL projects, and mostly the mobile clients. These were all open source. And I'll be talking today a little about the iOS Swift client I've worked on. But GraphQL is a topic that is pretty unknown still in sort of the mobile development community. So a large part of this talk will also be about sort of introducing GraphQL, why it was created, who created it, and what it actually is. But before I start with that, I'm curious how many of you have heard of GraphQL before? Okay, that's actually a fair number. How many of you think they know what GraphQL is? Yeah, that's a lot less. And how many of you have used it? So only a couple of people. Still a few. So GraphQL is not actually a new technology. Some of you may remember the Facebook app, the main Facebook app back in 2012. It was actually an HTML5 app at sort of the start of the year. And that was an app that was not well received. It didn't perform well, and it had like various kinds of bugs. And the team at Facebook set out to sort of completely redesign the Facebook app as a native app. And as part of that project, they developed GraphQL. So the question they asked themselves was basically, what would an ideal API for mobile apps look like? And if you sort of go back to the world in 2012, if you go back to sort of what Facebook looked like back then, it was a website, a web app. So it was written in PHP. It did mostly server-side rendering, or maybe completely server-side rendering. So it was a very sort of simple development environment. It was fast-moving. It was really easy to sort of make a change, deploy it, get all your users on the new version. And they wanted to keep that velocity when moving to native mobile apps. But of course, there are various sort of issues with mobile apps that that weren't really part of the web development experience back then. And I'll talk a little about sort of what those are in a moment. But it's interesting from a historical perspective that GraphQL was created for mobile apps, but is actually most well known nowadays for web apps. And I think part of the reason is that the requirements of mobile apps in 2012 are very similar to the requirements of sort of modern web apps nowadays. And GraphQL was like an immense success within Facebook. It has powered the main Facebook iOS and Android apps since 2012. It currently sort of serves over 300 billion requests per day. Like the majority of requests from mobile apps are using GraphQL. It's also used increasingly in the web app. And like I said, it's sort of a historical accident that most conversations around GraphQL are in the web development community. And the main reason for that is that when people inside Facebook started talking about GraphQL, like a technology they had been using internally for a number of years, it was the React group. So the group at Facebook responsible for the React view layer, who started talking about their use of GraphQL. And this was in 2015. There were a few conference talks. They released an open source specification and a reference implementation in JavaScript for GraphQL. And things moved really fast from then on. So what we've seen, we actually organized the first GraphQL developer conference late last year. And these are some of the companies that showed up to that conference. It's really a technology that's being adopted by an increasing number of companies. We've seen the first sort of public GraphQL APIs, like the GitHub API. So it's a technology that's being adopted at sort of a high pace. But like we saw, mobile developers, it's still a relatively new technology. And part of the reason for that is that there weren't actually any GraphQL clients for mobile platforms around. Like Facebook had internal clients. They haven't open sourced them, and they're not planning to because they're really tied into the Facebook infrastructure. So for a long time, there were just the JavaScript clients. So before I show you and tell you about the iOS client and how to use GraphQL from iOS, let's talk about what GraphQL actually is. So why should you be interested in GraphQL? Why are these companies excited about GraphQL? And sort of the easiest way in, especially for mobile developers, is to start out with sort of concrete problems that we're all familiar with. So imagine you're creating an app that shows a list of GitHub repositories. So you have your typical RESTful API, and the GitHub API is a sort of relatively well-designed RESTful API. You have your endpoint, your repositories endpoint, and you get some data back. You actually get a lot of data back. So this is actual data from a request to that endpoint, just asking for the repositories in our Apollo GitHub organization, and this movie lasts a full minute. So this is a lot of data, and that takes sort of bandwidth. It also takes processing, and it's something that really slows down your app, especially on sort of slower connections, slower devices. But it probably doesn't give you the exact data you need for a specific screen. So let's say you don't just want to show a list of repositories, but you also want to show sort of the top 3 contributors. With a RESTful API, that often means that you have to make sort of extra round trips to get that information. So here we make an extra request for every repository in the list to get the list of contributors. And again, for every repository, we get a list of contributors with a lot of information that we don't actually need if we're, let's say, only showing the name of the top contributors. So this is a well-known problem. Like I think most mobile developers are familiar with this. But of course, it's not an unsolvable problem. Like we all deal with this. You can deal with this within sort of a RESTful API paradigm, but it comes at a significant cost. And I think one way of putting that is that there's a real tension between, on the one hand, only getting the data you need for a specific screen as a specific client, and on the other hand, keeping the number of sort of REST endpoints on your backend manageable. And that may even manifest itself as sort of tension between teams. So you have your product teams or your iOS teams and Android teams, and you're working on a new feature. You need sort of data in an efficient way, and now you're suddenly dependent on the backend team to implement an endpoint. Or you may find yourself in discussions over sort of whether that specific endpoint is needed, or whether you can sort of adapt another endpoint, whether you can work around something, whether it's really a problem to make these extra requests. But suddenly you're blocked on the backend team. And this is what I would say the fundamental problem of RESTful APIs. So the question the Facebook team working on GraphQL asked themselves is basically, why would we let the server decide what data to return? And I think that's a really good question to ask. So we can talk a lot about sort of the RESTful paradigm and REST as an architectural style and where it came from. But if you approach things from a more pragmatic point of view, sort of what apps, in this case mobile apps, really need from an API, I think it makes a lot of sense to say, instead of letting the server specify what data it returns. Let clients specify the exact data they need. But then do that in a very sort of structured way against capabilities exposed by the server. So what does that look like? Well, very simple actually. So what you get back from a GraphQL API in the majority of cases is just JSON. So this is just a JSON response. And GraphQL has been designed to sort of resemble the structure of the response that you get back. So on the left, you see a GraphQL query. And you can see from the nesting that it really sort of corresponds well to the response you get back. You ask for a list of posts, and for every post you ask for the title. But maybe you want more. You also want the first name of the author. It's just an extra level of nesting. It's an extra field that you're requesting. And this is something that's fairly easy to sort of learn for app developers. That's something you can experiment with in interactive tools. I'll show examples of that later. But at the same time, it's a very principled way of doing querying against an API. So, of course, there are alternatives to this within the RESTful paradigm. Like you can come up with sort of arbitrary query parameters, like an include or a skip, or like any way of sort of working around the limitations of a pure REST style. But this is a very principled way. And one of the reasons is that not only do we have the GraphQL query language, we also have the GraphQL schema language. So the server actually exposes what you call a schema, a typed representation of sort of the capabilities that it exposes to clients, and then clients specify queries against that schema. So every query can actually be validated against this schema. We know what types, what the types of each field are, and it's a very sort of strong contract between the client and the server. So it has advantages for sort of for users, but also for tooling, and it even has sort of self-documenting capabilities built in. So you can actually generate API documentation from the schema. So instead of having a separate schema language on top of, let's say, a RESTful API, the schema is really part of your implementation, but at the same time exposes this sort of extra information. So one sort of aside, the fields you see in a GraphQL schema are not just sort of primitive properties. They're actually more similar to functions. They're actually sort of functions, and they take arguments. So you use arguments to parameterize these sort of field calls in a GraphQL query. So I started out sort of comparing GraphQL to REST by talking about overfetching and avoiding extra round trips, and that's an important part of why GraphQL offers so many advantages for mobile developers. But I would say it's not sort of the main reason for choosing GraphQL. So what's even more important is that GraphQL has really been designed with sort of the need of app developers in mind. It's something that has been designed not from a server perspective, but from the perspective of the client developers. And it offers a really nice developer experience. So a good example of that is graphical. This is a tool that was built by someone at Facebook. It's open source. And it uses the introspection capabilities of a GraphQL server. So a GraphQL server actually sort of exposes its schema, and it then gives you an interactive query editor. So I can execute a query. I get the exact data back that I want. Say I want the number of votes. I can ask for something that's not in there, so I get a validation error. So it's a very nice way of sort of exploring an API, composing queries, and it really shows the sort of developer friendliness of what GraphQL is about. Wait, this is always. So GraphQL has sort of many more capabilities. It's a fairly sophisticated type system. It has the notion of sort of optionality or a nullability built in, which ties in really well with Swift, as we'll see. It has a notion of enums, custom scalars for specific types like timestamps or URLs. It has a notion of interfaces and unions. So it's a fairly complete type system. And something else to mention is that GraphQL is not just a sort of read API. It also offers the capability to mutate data on the server. And the way it does this is through mutation operations. Mutation operations are very similar to GraphQL queries, but they rely on specific mutation fields that have side effects. They're basically functions with side effects. So the top sort of upvote post field here has a side effect. It upvotes a post, but then the rest of it acts as an ordinary GraphQL query. So you can actually ask for sort of the specific information you want returned from the server that may have changed as a result of this mutation. If you want to know more about sort of GraphQL, the language, there's a really good website, graphql.org. All the sort of code samples here are actually interactive, so they're graphical instances in the website. So that's a really nice experience. So to summarize sort of the benefits of GraphQL, I really think it sort of changes the relationship between app developers and backend teams, as it really empowers and unblocks app developers. But at the same time, it also sort of, by clearly delineating the different roles, it makes life for backend developers a lot sort of easier and more fun. They can focus on the things that they're best at. So they can focus on exposing capabilities in sort of an efficient way, in a way that makes sense to app developers, instead of having these discussions on individual sort of app requests, app screens, features for individual clients. Another benefit of GraphQL is that because clients specify the exact data they need, there's less need for sort of versioning your API. And this point is a little more controversial. The idea is that you can evolve a schema in a sort of continuous manner. As long as you make sure that the changes to your schema are backwards compatible, so you're not removing fields that old clients rely on, for instance, there's no need to sort of deploy a completely new version of your API. And Facebook has taken this to the extreme. So they've never made an incompatible change to their schema over the last 5 years. And they claim that even their 2012 client still runs against the same endpoint. So at their scale, if they can do this with sort of hundreds of versions running against the same endpoint, it's probably something most of us can also deal with. So before I finally get to the client, a little bit about the server, because it might, sort of the question you might ask yourself is, this sounds nice, but I don't have a GraphQL API, so how do I get one? And what you want to realize is that GraphQL is not a sort of database query language or a language that relies on a specific storage technology or backend technology. It's really a very thin layer on top of any backend that offers an application-specific view on the data that lives in your organization or team or project. So the way that works is it's based, again, on this notion of fields as functions. So you use these fields in the queries you specify as a client. And on the server, you define resolver functions for every individual function, for every individual field. And these resolver functions are arbitrary functions. The way you write them, of course, depends on the server environment. This is JavaScript. But they can perform arbitrary processing. They can also return data asynchronously. And the GraphQL server is the part that's responsible for parsing a query, validating it, and then sort of executing these resolver functions one by one, sort of walking the query tree, and in that way building up a response. So it's really a technology that works with any backend. A common situation is sort of a single GraphQL schema against multiple backends, which is really nice for sort of larger organizations with a microservices architecture or multiple types of backends. You can sort of hide the complexity of that underlying architecture by exposing a single sort of nicely designed schema to your clients. And then clients don't have to know so which parts of the schema come from which backend. And you can even follow relationships between data stored in those different backends. So let's say your customer information is stored in one system, your sales information is stored in another, you can still follow a relationship between them. So there are implementations and tools for a variety of languages. There are sort of well-known, mature implementations of GraphQL on the server for JavaScript, of course, for Java, for Ruby, for Python, for Scala, and I'm definitely forgetting a few others. So I think there's something for everyone there. And then the client. So what does GraphQL usage look like from a client perspective? So we've seen how you use GraphQL from a tool like graphical, like you just type a GraphQL query as a string and you get back JSON. And in fact, that's sort of the simplest way of using GraphQL. A GraphQL request is just an HTTP request. So in this case, we're passing in the GraphQL query as a query parameter, and we get back JSON. And this actually works fine for sort of simple tools. So if you're writing, I don't know, a simple shell script, this may actually be a fine way of using GraphQL. And it's very similar to what you would get with REST. But you're not taking full advantage of what GraphQL has to offer. So this is a project I've been working on. It's Apollo iOS, and I've described it as a strongly typed caching GraphQL client for iOS written in Swift. So what does that mean? Well, once you have a JSON response, what do you do with it? And of course, we all know that the pain of manually trying to deal with a JSON response. Like you use the built-in JSON serialization, but then what you get back is untyped dictionaries and arrays, and you have to manually cast those to right types. You have to deal with errors, with potentially optional values. So in practice, of course, like this is not something you would want to write yourself. Definitely not something you would want to sort of put in your UI code directly. So what most people do is they define some kind of model layer. And there are, of course, like hundreds of different ways of doing this. But in the end, what you want is you want the ability to take a JSON response and get back typed models. And this is, I mean, one of the reasons there are so many JSON modeling libraries for Swift. And they all take slightly different approaches, but they all require you to sort of specify the mapping between the JSON response and the model types, or at least define the model types. And that is sort of superfluous because we already have the schema. We already have a clearly defined type system. So an improvement over that model is to use the schema to co-generate a model layer that is able to sort of instantiate itself from these JSON responses. And again, this works. It's an improvement. But it doesn't take full advantage of what GraphQL gives you. Because remember, GraphQL allows you to specify the exact data you need. And if you define your model objects in terms of the schema, your model objects will contain a lot of fields that will not actually be filled for most queries. So here we have a response that only contains a title, but our post struct also has properties for the number of votes and the author. Which means that they're all, from the perspective of Swift, optional. And we have to deal with this optionality in our code all the time. So we can do better. And we can generate, again, co-generate query-specific types. So we take not just the schema, but the schema and the queries to generate types that are specific to a query, specific to a response for a particular query. In this case, we're asking for the title and the first name of the author. So the post and the author structure see here are specific to the post query, and they only contain that data. So what is that? I mean, that's sort of, I think, one of the main benefits of using a client like Apollo iOS. It gives you static type safety all the way from the server to the UI. But what does that look like in practice? And this, I think, is really neat part of the demo. So this is using a GraphQL plugin for Xcode that I wrote. Of course, it's not a real plugin, especially in Xcode 8. We've sort of lost the ability to do sophisticated things with plugins, but it's a grammar definition. So it does syntax highlighting, and it registers a new file type. And here we have a all posts query, and this .graphql file is taken in as input for the code generation step, and then generates an all posts query. And we can use that all posts query to execute the query, and what we get back is actually a typed result. So here we actually get back all post query.data.post, an array of posts. So these are the specific query specific posts objects. But then this query uses a GraphQL feature called fragments, and fragments basically allow you to abstract or sort of modularize parts of your query. And the great benefit of this when sort of defining these queries as part of sort of a UI binding, like we do here, I should probably show you the app real quick, because that may help clarify what this is about. It's a very simple app. It's basically a table view with a list of posts and the ability to upvote them. So what we do here is we actually configure the table view cell with the post details fragment, with the type generated for that fragment. From the perspective of the table view, like we don't actually know what data the table view cell needs. That is something the table view cell should define itself. And what's really neat about this Xcode integration is that it can use the companion view feature of Xcode to associate .graphql files with your .swift file. So if I go to a table view cell here, you can see the .graphql file on the right also changing. So you also have you always have the data needs of your UI components sort of right next to the UI code you're writing. And again here, the configure method takes a post details value. You get full code completion here. So these are the sort of properties that are actually available. This is the data that you can be sure is available at that point in your app. But if I, for instance, comment out the title here, I get an immediate compile time error. So I'm never in a situation where my server doesn't return the data I think it returns, and then my UI does something unexpected. I can actually rely on the Swift type system. So if something is sort of non-optional, I can be sure there's actually a value there that came from the server. So it's a very, very nice way of, like I said, giving you sort of static type safety for data that comes from the server. And this, another nice feature is that we also get full validation in the GraphQL view. So here I'm trying to query for the email of an author, but that's not something defined on the schema. So I immediately know that's not something I can query for here. And then few other nice things. Of course, these generated types can be used as input to helper methods. So here we are using post details to generate a byline. We can also extend them. So define helper methods like full name here. And we're using a mutation here, the upvote post mutation. And upvote post mutation is used to upvote a post based on a post ID and then returns updated information, including the updated vote count. I'll say a little more about how that is actually used to update the UI, because that's done in a sort of reactive, automatic way, because Apollo iOS includes a normalized cache. So back to the presentation. So again, these generated types, they're value types, which gives you sort of the standard benefits of Swift value types. They're thread safe. And another benefit of having these sort of value types instead of something like core data is that you can actually be sure that the data you request is there when you get past one of these types. And of course, because they're value types, that isn't just sort of the top level, but it's deep. It means that all the data is there. Because conceptually, it's one value. Like the data for your all post query is conceptually one value. So with core data, because you can do sort of arbitrary navigation, you don't specify what data you need in advance. There's always the danger of sort of triggering a fault on the main thread, and then you're blocked on database access. With a system like this, you're always sure that once you get a value, it's actually there, and it's all there. All the data you can actually access is there. Like all the network communication, all the sort of JSON parsing is of course done off the main thread, and that sort of makes it significantly easier to do these things in a performant way. I already mentioned caching. Like one of the things people often ask about GraphQL when you compare it to REST is, what about caching? Because REST has sort of well-defined caching semantics based on sort of HTTP protocol features. And it's true that GraphQL doesn't really take advantage of those features of the HTTP protocol. In fact, it's sort of completely independent of the network protocol, GraphQL. But I would argue that that's actually for APIs, that's a fairly limited notion of caching anyway, because all you're doing is caching individual responses. And in many cases, those responses, like different responses, actually return the same data or data from the same object. So the kind of caching GraphQL allows you to do in a very automatic way is what you might call normalized caching. And this gives you sort of automatic data consistency and the ability to get sort of reactive UI updates for free. So one way of looking at a use case for normalized caching is a master detail view, and I took this from an Android presentation, but of course the concept is similar. So you have a master list of repositories with a number of votes. You have a detail view of sort of an individual repository where you can upvote a post. Let's say you're on the detail view, you upvote the post, you then go back to the master list. What is the number of votes? What should the number of votes be there? Like if you cache individual responses, like the master list and the detail view are probably doing separate requests. They will be cached separately. You either have to sort of live with inconsistencies or manually update the number of votes in the master list, which is a big pain and sort of prone to errors. So what normalized caching allows you to do is basically say, we need a global identity for every sort of object, every record that can possibly be returned. And instead of storing responses as a whole, as a tree, we break up these responses. We break them up into individual objects. We then sort of merge every response into the normalized cache. So we always have a consistent view on sort of individual objects, which has the benefit that we can use that to automatically update other parts of our app. But it also gives us the ability to load data from the cache directly when everything is actually already there. So there's much more to say about this, and it's also an area where we're sort of actively working on improving both the sort of fundamentals and the programming interface. So if you want to get involved, that of course would be even better. But the basic idea is that it gives you one-way data flow. So because every update goes through sort of this centralized normalized cache, this store, things like incorporating mutation results, but also doing optimistic updates. So updating your UI before a result from the server comes back. And then if for some reason the result from the server isn't what you expected or is an error, roll back that change. Doing real-time updates over WebSockets. There's a proposal for GraphQL, and we have implementations of this to add subscriptions that allow you to get real-time updates for parts of your data. And these all go through the same store. So you have a common mechanism that you use to sort of bind your data to your UI. We've also released an Apollo Android client, and this is something I'm really happy with. I'm not an Android developer, and I was really dreading having to work on an Android client. And I mean, working on the iOS client was already a lot of work. And we were really lucky to find a great group of contributors from companies like Shopify and New York Times and Airbnb. And basically, I've been involved, especially at the start, as sort of a design advisor, but they've done like all of the work themselves, and it's one of the most active projects on the Apollo organization right now. And they're all sort of actively using the project, either in sort of side projects or in their main app. Airbnb is also contributing now to the iOS client. So they've recently landed a SQLite cache, which I'm really happy with. So we're trying to sort of really, like the whole set of Apollo projects are community driven. They're open source projects. Like we work on these because we want to grow GraphQL. And as a company, of course, we also have commercial interests. So we're working on sort of GraphQL developer tools. We have a performance monitoring insight tool for servers, but we have other products we work on and services we offer. But the open source projects are all sort of part of the GraphQL community, and we really hope we can get as many people involved as possible. So especially the mobile projects, I mean, these are really great contributors, but it would be even better to get a larger group of contributors for more diversity and people who actually use this in like different types of apps, different types of organizations. Because one of the things we want to accomplish with these Apollo clients is sort of a unified set of clients across platforms. So we've taken a lot of design principles from, well, first of all, what we've learned from Facebook, either like in presentations and by talking to the team. Like we've learned a lot from sort of their experiences over the last 5 years. And then the JavaScript client recently reached 1.0 after a year. It's currently the most popular GraphQL client in JavaScript. And we're taking lessons from sort of the JavaScript client on the one hand, the mobile clients at Facebook on the other hand, and trying to come up with sort of common design principles, common APIs. And we're even working on further integrating these clients at runtime. So one use case we're excited about, and this comes from requirements from Airbnb, is to not just use GraphQL from React Native, because that's already possible with the JavaScript client, but actually integrate React Native views with native views in the same app. That's something the Airbnb app does. Like more people who are incrementally adopting React Native do this. But if you want to do this in an efficient way, you actually want to share the store, share the cache between native and React Native. So that's one of the next projects we'll be working on as well. All right. So if you're interested in either GraphQL in general or like the mobile clients I've talked about. There's the GraphQL.org website with like great documentation on the GraphQL language. There's the Apollo developer blog where we sort of post regularly about the different clients and the features we're working on. And we're also hiring. So if you're interested in working on GraphQL full-time, definitely get in touch. Yeah, I'm looking forward to having some great discussions with people about this.